Okay, we ready to get started? All right, go to page 78. Let me show you something on page 78. Oh, listen to that rain. Starting on this page 78.
Players love the street. Nowadays, high school players don't even win.
Yeah. And then in chapter 2, is it after the homework problems? Yeah, it's after all the problems. It looks like it's an appendix 2.1. A different, yeah. If you index has a different edition, it's gonna be it's like 91 maybe, and the last two editions possibly, right around there. This tells you how to set up Excel. Right here, the next page, and a third page. Step by step. I'm just going to put it in my own words. Just want to show you a little bit more on this page right over here at the top. But it pretty much looks like this. What's going on there is each of the constraints are up there, and the numbers that go with the variables are put to the right. Standard is whatever variable that is, ds, and deluxe is d. So that first constraint should be 0.7s plus 1d, and then 630, I'll look down here, less than equal to 630. And that's how you set it up. At the top is just data entry. Now let's look at this one. And I posted this. So now you all have this. What's going on up here? What did this happen? What is this? Where did this come from? I don't know. There we go. There's S and D. First constraint, 0.7s plus 1d equals 630. If the original constraint said 0.7s minus 1d, or minus d is less than equal to 630, you put a negative 1 there instead of positive. That's how you represent minus. And there's each constraint. Now here is the numbers that are on the objective function value. In this problem from the PowerPoint, it was a 10 and a 9, or from page, you can see in there, on here also. It's the problem that goes all through chapter 2, same one in our PowerPoint. It was 10 with S and 9. This was the amount of profit on the standard and deluxe. Remember I told you the story in real life, how companies do have standard and deluxe, and even a better one, and they almost always make more profit, not less profit, as they become more expensive. The good, better, best marketing system that's been around forever. But this one's 10 and 9. Here, you start out leaving these either blank or zeros. This is where the values, the optimal solution will show up when you use Excel to do the calculation. So you just put zeros there. There's no, if I were to click in these cells, there's no formulas, just a zero. And all these cells, no formulas yet. This is all data entry at the top part. Now, I always suggest that if you're going to use this on homework or a quiz, but let's say the problem only has 4 constraints or 3 constraints, just take this, resave it, rename it, and now start changing it. Eliminate that line, just get rid of that line, and everything moves up. And just change whatever needs to be changed to fit the problem you're doing, and you get to save a ton of work. You don't have to start making this from scratch all over again. This works if you have to add a constraint. Insert row. And then you add it, you put constraint 5, and you put the numbers in. Here, from here down, are formulas. And so like this formula, before I show you, because you know it's the objective function value, it means whatever the optimal solution is for S times the number in the objective function for S. So if this is 200, 200 times 10, plus this formula is going to say whatever the number is, optimal solution for D, times the number that goes with D. So this cell is going to be, this is E, and you can't see it. I gotta switch this. Over there? Is it there now? Yeah. All right. So this is going to be D11, that one's, or I'm sorry, E11, F11. Did I accidentally add something? And then this is going to be E16. So let's think about this for a second. You ready? Help you how this starts based on what I just told you. This is going to be equals. What would be next? Give me a cell location. Equals, and then a cell location. It's the optimal solution times the values that are part of the objective function that go with the variables. Do you see the cell location for the optimal solution? Right there. E16, and then multiplied by, whoops, E11, plus F16 multiplied by F11. Exactly how it is in the objective function when you took your homework and you put that optimal solution into the objective function, you would have calculated the objective function value, and you would have taken whatever numbers for S, you would have plugged in and make it times whatever that number is in your objective function on the homework. And then you would have added to whatever numbers for D and times the number with that variable. Your variables, though, were two different ones, but the logic's still the same. If you were doing the homework, you would have put this in whatever two numbers that are in your objective function. Now, these formulas down here where the constraints are, before I show you, think about constraints. If you were putting the optimal solution into each constraint so you can calculate either the slack or surplus, that's what's written here. It's cell locations. So it would be whatever the optimal solution is for S times the number with S in that constraint, which is right there. Plus whatever number the optimal solution is for D, which is right there, times the number in that first constraint that goes with D, which is right there. So, sure enough, it's E16 times E7 plus F7 times F16. You see what's going on here? The optimal solution times the numbers in that constraint. So, before I go on to this next one, someone volunteer who thinks they're getting this, what cell locations would be in this one right here, the next one down, for the second constraint? You mean any cell location to start with? What, 8? I heard something 8. E8, very good. Then what? Times plus? Times E16, very good. Plus or minus? Plus F8, perfect, times, that's it, that's exactly what's in that cell, you're getting it. And if you only have 3 constraints on what you're doing here, just get rid of this down here also. Now, all of these are the formulas exactly as you just described. The next one would be for the third constraint, the next one would be for the fourth constraint. This times this, plus this times this, and the next one. Here's just for visual, just to remind you whether it's a less than or a greater than. These have nothing to do with any calculations at all. You're just throwing those in there so you don't have to go back and keep finding the constraint to try to remember, is that a less than equal or is this a greater than equal? This is a formula that is looking up at your data to figure out what the right-hand side is for constraint 1. So this just says equals H7. So this one, where the 600 is, just says equals H8, equals H9, equals H10. So as you're plugging in the right-hand sides here, or typing it in, they show up right here. All the computers calculating everything in here and right in here. But it's just referring to the data you entered. So you've entered all the data from here up, zeros here, and then all formulas referring to cell locations, all of this. Forget about this. I put that on there for our own entertainment. Because I just want to see if I can come up with something to do slack or surplus. At this point, I'm not requiring you to calculate slack or surplus on Excel at the moment. But you should. But maybe, I don't even know, what did I put here? Okay, I just said, this is going to end up, not that, where is it? This is going to turn out to be, if this is a binding constraint, it's going to say 630. But if it's not a binding constraint, and they say some other number, so I have these two numbers being subtracted, and then I added the word slack only because I saw this. But if this were greater than equal, I would have put the word. Am I using a word, or am I, oh no, I'm using an if statement. We haven't learned if statements yet, but I'm sure some of you have experienced Excel enough to use if statement. So I'm just going back to look and see if that's a less than equal or greater than equal. And if it's a less than equal, then put the word slack there. If it's not, then put the word surplus, because process of elimination. So now I guess we are going to use it. Yes?
If we have to go through and change the signs, we also have to change.
No, what will happen is, watch what happens. If I change that, that word will change the surplus automatically. Again, I don't know what it did. Oh, it did. I thought I'd have to go back up and do the underline here, but it stayed from being in there, and sure enough, see what happened. All right, you ready to learn how to solve it? Again, tells you right back here. Now this starts on page 80, how to solve it. Now, some of you will go home and look at your computers and say, hey, my Excel doesn't have, let me go to data, it's called solver. And we're going to be using data analysis down the road. So you want to go to File, you want to drop down here to, I think it's Options, and there should be Add-ins. There it is, Add-ins. I don't remember where to go from here, but I think it's like here or something, or up here. Analysis tool pack, and then I don't know, what does it say here? Excel add-ons or something, and you click on Go. It's been a long time since I've done it, but you see what happens. Yeah, there it is. You would click on the analysis tool pack, the solver add-in right there. You can click OK. Give it a minute. You may even see something spinning. It takes a little bit of time. It's now installing that whole add-on onto your Excel for you. And we cancel, I already have it. And then all of a sudden you'll see this pop up at the top here under data. It will go data tab and then solver. Now you open up solver to do this. Oh, I got it all in there. Stop looking. Hang on, stop looking. This is a learning experience. Hang on. Hang on. We gotta get these out of here. Delete. Delete. I want you to see how this is done from scratch, because you won't have anything anywhere else. Here. Okay, here we go. You open this up, it should be blank. Right there. Let me scoot it over. Now these words are kind of difficult. It's at the top. And if this is on your quiz, and because I left Excel off on the last quiz, there's like a 99.9% chance you had Excel on this next quiz. Because there should have been some on the first quiz, so you're definitely going to have it. If this were a quiz, it's possible you may see a picture just like this. And I may say, what cell location would you put in set objective? And it should be whatever cell is calculating your objective function value. Whatever cell is calculating your objective function value. In our case, that's going to be, what is that, E18? Is that right? And you don't have to type E18, but you could. I have my pointer or cursor already blinking there. And now I'm just going to left click on the cell location, and it will put $, what is that, E, $18, right? Right there. So now I'm going to go down here. Is this a max problem or a min? A min? Max?
Is this somewhere?
Yeah, this is the one on the PowerPoint in the book. Max, I think, isn't it? Because all the constraints were less than equal, it's got to be max. Okay? Now, right here it says, by changing variable cells. This is the cell locations wherever your optimal solution is going to arrive. Let me repeat that, because on a quiz it will say, what would you enter in by changing variable cells? By changing variable cells. And you got to find whatever cell locations where the optimal solution is going to be put when it does its thing. In this case, the optimal solution is going to be decision variables, whatever that number turns out to be, and whatever that turns out to be, that is the optimal solution. And we're heading right in the very next chapter in 4, where you're going to have 5 variables. So you need to put all of the cells that were variables where you want the optimal solution for every variable. In this case, we have 2. So all I got to put is from here, and then I put, it's been a long time. Is it a colon? Thank you. Colon, and then I'll put the other one, which is right here. And so it says $E, $16, through, $F, $16 with the colon in the middle. But if I had 5, I would have said here to here. So the back part would have been $I, $16. By the way, $ in Excel means if you copy and paste, that $ is saying don't change that cell. Don't change what I wrote there. That's what the $ means. Keep that in F all the time, keep that at 16. We're heading to several chapters where we have to copy and paste into a whole bunch of cells below, and you won't want it to change. So when you have the original one you typed out, before you copy and paste it 999 times below it, you want to make sure you got the $ before the letter and the number if you don't want it to change. You're going to have that. We got to get to a point where I'm asking you, $ or no $, you say you've got to know whether you should be using one there or not, based on whether you are okay with it changing or not changing when you paste it. $ means Excel, don't change this. Whichever way I paste this, leave it as FE16 or something. Okay, subject to constraints. This is where you're going to put the cell location of the left side of the constraint. Then you're going to let it know, is it less than equal or greater than equal? And then you got to tell the cell location of the right side. So in this case, we have, what is that, E21. That's supposed to be less than equal. I changed it to see what would happen. But. And then we're going to put H21. So it looks like this. Let's see, I'm going to add. It says cell reference. You might as well just write the words left-hand side of constraint location. In this case, it's going to be E22. So 22 or 21? 21. So I clicked on it, and it put E21. Now you go here to the center and open up this down box here, this, whatever it's called. Help me out. And you figure out which option you're putting there. It's either going to be less than equal, greater than equal, or equal. You get these. In this case, it's a less than equal. So you put less than equal. And then constraint, put somewhere on there. This means the right-hand side of the constraint. The word constraint means put the cell location of where the right-hand side of that constraint is. The right-hand side is right here at H21. So I've got F21 less than equal H21. And then you repeat this for each constraint. And if you have constraints that in a row are all the same sign, you can shortcut it. You want to see that? So let me finish this one. I'm going to put OK. And there's that constraint right there. And now I want to add the second constraint. I could have added it right then and not go back to this, but I want you to see what's going on. Add another one. Now I don't want to type the whole thing again. So I know that all three of these are all less than equal. So I'm going to take a little shortcut here, and I'm going to say, I want the cell reference to be E21 all the way to E24. So I'm sorry, E22. E22 colon F20 or E24. That's three of them in a row because they're all less than equal. So I open this up, make sure it's less than equal. And then the right side's got to be the same number of cells to match up with the left side. So the right side is going to be H22 through H24. H22 colon H24. So you could do them all three of those separately. These were all less than equal, so you could have done all four of these separately, or you could do all four of them in one, because they're all the same sign. There you go. Excuse me. Felt that one coming. Here we go. So now we have the first constraint, and then the other three are grouped together, because they're all less than equal. This is all you have left now. You must check this box, because for this semester, every linear programming problem we have, the variables are non-negative. Remember that I said you don't have to put x and y are both greater than equal to 0 at the end? This is what you're doing here by checking that box. All the variables are always going to be positive, either 0 or a number of others. And then right here, you got to open this downward tab here, and we're doing simplex LP the whole semester. So the only one you're going to use for this class is simplex linear programming. Okay, everybody got it? First step, where the objective function is. Second step, max or min. Third step, where the decision variables optimal solutions want to be placed. Fourth step, put all your constraints left-hand sides and right-hand sides, and if they're less or greater than or equal. Check that box, non-negative box. Open the down thing and make sure you click on Simplex LP for linear programming. When I click solve, it's going to say, are you okay with this or do you want more information? And we want more information. So I'm hitting solve. Yes, keep the solution, but I want to add a sensitivity report. Like sensitivity analysis, which is additional information that you're going to see on the output when we use the software. And you need this information. So you click there, now you click OK. And you notice a tab opened up down here. It put a sensitivity report in this tab. But over here, it put the optimal solution. How many S's and how many S's should we tell? These are the golf bags. How many standard bags should we be making for the next 3 months? For that distributor said, I'll take all you can make. You see the answer there, anybody? 540, right there. How many deluxe bags? 252. This is the optimal solution. This is how many you should make of those golf bags for the next 3 months. We have a distributor. I just sent this information to the distributor. They said, yep, we're definitely sending you the PO, purchase order, for 540 and 252. Start production. The most we can make, the maximum profit with this combination, with there may be an alternative, but why look for it? This combination, the most we can make with all our restrictions of time in each of these departments, 6,668. If you plug 540 times 10, 252 times 9, the objective function numbers, that's what it turns out to be. So we got a lot of work for only $7,668 profit. For 3 months work, that doesn't seem like it. That barely covered a rent. I'm trying to say it won't even cover my beer tab. You ready? That's it. You've seen Excel. You ready for the software now? How do we feel about this Excel? Download it. Every time you use it, resave it under, change the name, and just start changing things. Play with it. You can't figure it out, send me what you've got done so far. I'll look it over. I'll tell you what you're doing wrong. You can change it again. All right? Let's go to the software. I posted the software, I think last night, under course information. Let's take a look real quick. I believe it's way down here at the bottom. Right there. Following instructions, you click on this zip thing, save it, maybe download or something. Go to where you saved it, right click, left click on extract, I think. Extract, decide where you want to extract it to. And when you extract it, it's going to look like, you're going to see a folder that has this, it's going to look like that. And now you just start using it. And to use it, right there, your executable file, you would usually double click on and it starts. Sorry, Macs. It's so difficult to get it work on Macs. I'm not going to go there. But there is a way. But it's very difficult. You have to have 2 operating systems, both iOS, and there's a way to partition it and then have Windows as another operating system, and then it will work. But for everybody that doesn't have Mac and Windows, the first time you use this, you're going to go, error message. Why do I keep getting this error message? For some reason, you got to right click on the executable file name right there, and left click on Run as Administrator the first time. After that, double click on it every time it works. It's just you have to run it as administrator once. Okay? Everybody get that? So when you download that software, run it, you get an error message, you're going to get an error message, and then run it again, right click, run as administrator. And then after that, it works everything. So I already opened it. When you open it, it looks like this. We're going to use a lot of these modules, but we're on module 1 right now in your program. I want to stick with the same problem that we just did on Excel. So I'm going to go back and forth and just enter the same numbers and see what we get. You click on linear programming, it's going to ask you, and then you go new, file new. We're doing a new one. It says number of decision variables. How many variables were in the golf bag linear programming problem? 2. Standard and deluxe. Then it says how many constraints. How many less than equals did we have? 4. Then it says, is this a max or a min? Max. Opens up. It always has X1 and X2. And all you got to do is click where it says X1 and switch it to the variable you're calling it, which is standard bags and deluxe bags. Whoops. And notice it switches automatically down below here. And then Here is your objective function. Every standard bag, we calculated that we will get $10 profit. Remember that 10S plus 9D is max. So I'm putting a 10 right here under the S, and I'm putting a 9 under the D. Let me go back to Excel so you can see what I'm doing here. I took the objective function numbers, 10 and 9, and I entered them at the top line where it says objective function coefficients on the software. Now, constraint 1. Real quick, I'm going right here. Every one of those constraints were less than equal, correct? So I'm just going to fill that in. Less than. Go down, less than. Go down. I already blew it, didn't I? Less than. Go down, less than. Go down, less than. So I got that done. You don't have to type equals. The software knows that when you put less than, it means less than equal. If you put greater than, it means greater than equal. If you put equal, it means equal. Those are your three choices to enter down those. Now the right-hand side, I'm just going to look here at Excel. I'm just going to throw those in. I got 630, 600, 708, and 135, right? Are all the right-hand side. 630, 600, so I'm throwing those in. 630, 600.
708.
Thank you. 708 and what?
135.
135. You know, I already forgot you were late. That's like extra credit. Just kidding. But that was probably easy. Okay. First constraint. What numbers with the S? What numbers with the D? 0.7 and a 1. So just do it just like you did in Excel. 0.7, 1. Give me the other numbers.
0.5.
0.5.
0.8333.
Okay, and constraint 3.
I don't know that one.
Constraint 3.
0.1. Oh wait, no. 1. And 0.6667.
0.66667. And the fourth constraint.
0.1.
0.1.
0.25.
0.25. Really? Yeah, that's so pretty good. Okay, that's it. Just like you did with Excel, you got it all filled in. You go up here to solution. You say solve. Are you ready for this? You sure? What is the solution? I want to make sure. What is it?
252 and 540.
Here we go then. Oh, what did we do wrong?
No.
Is that? I thought you said 5. Oh yeah, yeah.
539.
Rounded. Yeah. Does everybody see where the optimal solution is? The optimal solution is where the values for the variables are. You see them? This section up top is called the optimal solution. This is always where it's placed, up here. And these are the variables, and there's their optimal solution. At the very top is your objective function value. If I took 10 times 540, 9 times 252, and add them together, I would have got $7,668. Just like Excel should be 7,668. Let's take a look. 7,668. So, objective function values at top, your optimal solutions there. These are each of your constraints, and look what's giving you. It is not telling you whether it's slack or surplus. It's just telling you what the difference is. You still got to look at the original constraints and say, okay, is that slack or surplus? 0. 0 what? Slack, because the first constraint is less than equal. And matter of fact, every constraint is less than equal, so that'd be 0 slack, 120 slack, 0 slack, 18 slack. Right there. Here's a good question you'll see on a quiz. You're given an output. And one of the questions may say, which constraints are binding? All you have is this output. How are you going to tell me which constraints are binding? 1 and 2 is not it. I hear 1 and 3 over here. Why, Sierra? Why 1 and 3?
Because they're both 0 slack.
0 slack as your binding constraints. Remember that? And so, when you see these, this is basically telling you those are the two constraints that are crossing where that optimal solution is. And then I go down here. This section is your objective function numbers. Where it says current value, if we go back and look at the objective function, it says max 10s plus 9d. There's the current values. Now be careful. You're going to see at least 2 different, maybe 3 different software outputs in this class and in operations. And they all have the exact same information in different places, presented in a different way. So you've got to get familiar with this to understand. For example, there's a software output we're going to see maybe Thursday or today where it has the current value here. So you got to look, and it has these numbers or something like this will be here, and then these are here, but these are over here in a different order. So I've had students not realize this is a different output and give me the numbers are here, which are not the numbers. They're not the current values in the objective function, because now they're over here. So look at these outputs carefully. They all have this information, but in different places, including Excel. What do we have here? What was I point out? Current value, here's the lower limit, upper limit, and I'll go Excel. I'll show you that same thing. It's a 10, 6.3. How much, what's the difference here? That's 3.7? Okay, it's 10. It could go down 3.7 units, which I'll tell you why in a minute. And let's see what Excel, how does it present? We'll go to sensitivity. It's currently at 10, but it could decrease by 3.7. It's not giving you the, what was the number, 6.3? It doesn't say 6.3 like the other software. Excel is giving you the amount it could decrease. So if we took, though, 10 minus 3.7, go back to the software, it does equal 6.3. Look how much it could go up. It could go as high as 13.5, we'll call it, we'll round it. That is 3.5. Now if I go to Excel, it should say allowable increase. Here's this one, here's a 10, allowable increase, 3.5. So it's presenting the same information but different ways, and there's another way it's presenting it in another output that's in your book. Here we go. This is a different problem, but that's the same as the power or as the software. What's going on? There we go. Oh no, it's not. Here we go. Okay, here we go. What numbers are with the objective function? What variables are in the objective function in this problem? What variables? U and H. I heard it up here. U and H. Now, what numbers are with the objective function? If you could see it, what numbers with the U? No, not 800. 3. Here's the objective function part right here. Here's U, but the current value, they're calling it the objective coefficient on this software, and it's a 3. So 3U plus 5H. Max or min? We don't know. Which constraints are binding in this problem? Well, you guys got this down. Wow. All right. Easy points on a quiz, because you'll see a software. Probably the easiest question, 1 point will say, which constraints are binding? You said 1 and 2. How much could the number in the objective function with U increase before something happens, which I'm going to explain here in a little bit? How much can it increase? I like Alex, that's what I would have said, because I know that the number, if it's given me the upper limit, then I would say, oh, it can only increase 4. But this software doesn't give you the upper limit, it gives you the amount that it could increase, so the upper limit is 10. You've got to add these instead of subtracting. So you got to get used to these. Again, same information, just presented in different ways. All right, let's go back to the software. This last section is all about the constraints. The right-hand side of every constraint is somewhere in there. And then, what is this? What are we looking at here? It's the same one. Still, though, I'm saying the same thing. Here it is, all the constraints. And somewhere in here on these constraints is the right-hand side of each constraint. Everybody see it? What's the right-hand side of the second constraint? Can't hear it. What's the right-hand side of the second constraint when you look at this? 600. Current value. First constraint 600. Excuse me. Second constraint 600, 708, 135. And on that other software, on the other software output, this will be here again. And instead of a lower and upper limit, it will be allowable decrease, whatever the difference here. We'll say allowable increase, whatever the, what is that, 52.366. It will give you the amounts. As a matter of fact, let's go to Excel, and that's how Excel does it also. Current value is 630. It could increase by 52.36, so it could go as high as 682.3636, Or it could go as low as, we would subtract 134 and find that lower limit. But on the software, it's giving you the lower limit. And if we need to know how much it could go down, you'd have to subtract these to find it. Jump in.
What is the lower limit and upper limit? Like, let's say.
That's where we're going.
Okay.
You ready? Let's start with the objective function lower limit and upper limit. One variable at a time. This is where I start to lose people, so I want to make sure everybody's hearing me. The lower and upper limit, or the amount it could increase and decrease, is telling you, now here in business, you have this output. You got to make decisions fast. So I'm going to say, hey, the amount of profit on that standard bag, because we just changed the process of making it, is no longer $10, it's $9. We had to add an additional 30 minutes to get this little thing to work right. Well, it's only $9 now. Should we still be making 540 standard bags and 252 deluxe bags, or do we need to stop the production process right now and recalculate because we may have already made too many standard bags with this change? You quickly look at your output and you go, oh, $9 is within the lower limit. And because that new profit is within the lower limit, our optimal solution is still valid. Do not change production. Keep working, and we're going to keep making 540 and 252. But if you came in and told me that our profit on there is now $6, stop. I need to redo all this because we may have already made too many standard bags. Get it? Let me ask you another question. Ready? Oh, you aren't going to believe this. Finance just said because of something that we're now going to make more money off the deluxe bag. Instead of $9, we're going to make $11 off every deluxe bag. Do we got to change manufacturing? Are we still making 540 standard bags? Yes or no?
Yes.
Because that increase in profit from 9 to 11 is within the upper limit. Now, I want you to be careful. Think about this. You may be looking at a software output that tells you how many units it could increase. And the sentence says the profit from the deluxe bag went from $9 to $11. Is the optimal solution still valid? I want to really highlight something here. I said all the questions related to these limits are all about you telling me if the optimal solution for those variables are still valid, yes or no. If it's yes, you say yes, still valid. And you tell me why, whatever. If it's no, though, every one of these say, if you say no, calculate the new objective function value. No, I'm sorry. Change those notes. If you say yes, change that. If you say yes, what's the new objective function value? Now let me explain. This going from 9 to 11, yes, we're still making 540 and 252. But that objective function value, that $7,668, was based on the profit of 10 times 540 and 9 times 252. We're not making 9 now. We're making 11. So now it's 10 times 540 because it's within the range. We're still making 540 and 252, but now we got to take 11 times 252. A shortcut for people who love math. 9 to 11 is $2 more profit on just the deluxe. So $2 times 252 deluxe bags, additional profit. Then you can add it. If you hate math, take the 10 times the 540. And now the new profit of 11 times the 252 and add them together, and there's your new objective function value. Your objective function value is going up by $2 for every one of those deluxe bags. But you didn't have to change that. Now, if the change is outside the upper and lower limit, your answer is no, the optimal solution is no longer valid. This whole thing would have to be recalculated. And that's your whole answer. You don't have to give me a new objective function value. If the question will say yes or no, and show me your evidence, your work, then it will say if the optimal solution is still valid. If you said yes, you should calculate a new objective function value. Because even though they're still valid, the change caused that top number to be different. Everybody with me? Now the same logic goes with the constraint. Excuse me. The same logic goes with the constraints, upper and lower limits. This is where you gotta write a big number. Evaluating these upper and lower limits on constraints is all about answering the question if the dual prices, sometimes called dual values on other outputs, if they're still valid. Now let me catch you up. The right-hand side of the amount of hours we have in this department, which I can't remember, is cutting and finishing or something like that. You know, an employee who we thought we were going to be here for the 3 months, you know, has to take leave for some reason, and because of that, we are limited more on the hours we have in this department. So it's no longer 630 hours, we have 600 hours. And we just found this out, and we've already started production. We need to know now, you know, what are we going to do? Is the dual price still valid? Yes or no? I said it's going from 630 to 600, right? The lower limit is 495. Because that 600 is within that range, within that lower limit, the dual price of $4.37.5 cents, $4.37.5 is still valid. What does that dual price mean? It means for every unit of change here, this is the effect it's going to have on that objective function value up there. If this 630 and somehow we got an extra hour and it went to 631, that's a positive $4.37.5. A positive effect, because this is a maximization problem, would be additional profit. So we would add $4.37.5 to what that number is already. And that would be our new objective function value. Now be careful. Well, I'm about to lose everyone. Are you ready? Except for just a couple. Ready? If this is negative, it means negative effect. Doesn't automatically mean you subtract. This is positive, means positive effect. Doesn't automatically mean you add. If this is a minimization problem, a positive effect is subtracting. A positive effect is minimization, is you want that objective function to be as low as possible. You get it? So I want to make, this is where I'm losing everyone. I see some glassy eyes. You ready? Here we go. 630 is going up 2 units. Is it within its upper limit? Yes or no? So it's going from 630 to 632. 682 is within. So the question will say, is the dual value or dual price still valid? Yes or no? Yes. Because it's within the upper limit, blah, blah, blah. Now, if you say yes, it will say, if you say yes, calculate the new objective function value for this minimization problem. It went up. For every unit it increases, it's going to have a positive effect of $4.37.5. Because this is a minimization problem, the new objective function value is subtracting that from it. Subtract $4.37.5. You get it? I want to make sure you get it. You ready? Yeah, let me do another one. Constraint 3. Constraint 3 is at 708. And we just found out that we don't have 708 hours for the next 3 months in there. We only have 700. It's going down 8 units. Going down 8 units. Is the dual price still valid? Yes or no? How much did I say is going down? 8 units. It could go down how many? 128 units. Now it's cheaper. Yes, it's within there. It's only going down 8 units to 700. It could go all the way to 580. If we were looking at a different output, it would say allowable decrease of 128, and we're only going down 8. So we're within the range, right? The dual price, still valid. The dual price is a positive effect. Let me say this again. The dual price is a positive effect for every unit this goes up. A million. 708 to 708 is going to 700. This is a positive effect for every unit that goes up. Will you take $6.93 on a minimization problem? This is too typical. I don't know why anyone names it. It's too hard. What will you do? Say it again. Here's what she's saying. She said, this is going down. If this went up, it would have a positive effect. Well, see, I've already caught myself. I don't think it is subtract. If this is going up, it will have a positive effect, but this is a minimization problem, so you'd be subtracting it. This is going down 8 units. So 8 times 693.5, negative effect. It has to have the opposite effect because it's going down, not up. This is the effect if it goes up. So a negative effect, it's a minimization problem. We're adding 8 times $6.93.5 or whatever that is to the objective function value. That was tricky. First, because it's minimization. Second, because it's going down, not up.
So if you're trying to minimize, so if it's a minimized problem,
Yes.
you would add that 6 to the objective value.
Because this is going down,
So you have more.
and so it's not going to have a positive, a negative effect. And our minimization and a negative effect is that your minimization cost is going up. So that's why you would add it. When you look at these, don't automatically jump to, do I add or subtract? Get in the mindset of a manager who says, what would be a negative effect or a positive effect if this were max or min? Let's try another one. You ready? This is now a max. I want to say that again. This is now a maximization problem. Constraint 1 is going down 3 units. Is the dual price still valid? Yes, because it will go to 627. That's way within the lower limit. The resulting decrease is within the lower limit. You write this out. So yes, the dual price is still valid. It says if the dual price is still valid, calculate the new objective function value. How many units did I say? It's going down 3? If it goes up, it has a positive effect, and it's a max problem. But it's going down. So you have to do the opposite effect, which is going to be a negative effect of $4.37 times 3. Max problem, negative effect, do we add that or subtract that? Subtract, you got it. Negative effect on a max would be a subtraction, yes.
If this was a minimization problem, would those dual prices be negative?
Sometimes yes, but sometimes they're negative even on a, you can't go by whether it's max or min. You'll always be told whether it's max or min, because there's no way to calculate this without knowing. So you'll be told for sure whether it's a max or min. The hardest part is looking at this and going, okay, it's going down, but this is telling me the kind of effect it would have if it's going up. So it's got to have the opposite. So if this were negative, everybody, if this were a negative here, this is a negative dual price. The right-hand side of 708 is going up 2 units. Is that dual price negative 6.9 blah, blah, blah still valid? Yes or no? 708 is going up 2 units. Is that still valid? Yes. It says for every unit it goes up, it's going to have a negative effect. This is a maximization problem. And it's going up 2 units, so 2 times 6.9375. Add or subtract. A negative effect, max problem. Add or subtract? Subtract. Because a max problem, a negative effect, it would be lowering it. Because it probably represents profit. This isn't easy. You've got to think it through. I think she had a question real quick. Okay, sorry, back on.
I just wanted to be sure, so whatever difference you make within your constraints, you multiply that by your dual price.
That's right, because this represents the effect it will have on that objective function value for every 1 unit it goes up.
Okay.
Every 1 unit goes up, that will have a positive effect. Whether that means add or subtract, it's depending on max or min. For every unit that goes up, that will be a positive effect of that amount. Whether we add or subtract depends if it's a max or min. And every 1 unit goes down. Now, why only are these 2 constraints, 1 and 3, have dual prices? Why don't the other ones have dual prices?
No upper limits.
No, that's not why. But there's going to be problems with no upper limits, and they also have because they're binding constraints. The binding constraints, any change in the right-hand side of a binding constraint is going to affect that objective function value. But the other 2 constraints have either some slack or surplus, and they can adjust changes, and it won't affect the objective function value until you go beyond the amount of change. No upper limit, you can't go beyond that. But if this 600, which has no here, if that goes below 479, let's say it's going down 200 units. 600 is going down 200 units an hour for the next 3 months to 400. It's below there. You're going to say it is below the lower limit, or it's less. That's less than the allowable decrease. the dual price is no longer valid. And that's your whole answer, because it will say, if yes, calculate the new objective function value. But you just said the dual price is no longer valid, so there's no objective function value to calculate. But it's paid off for many students over the years that if you, even though you're saying you can't calculate the new objective function value because, you know, it's outside the limit, this has to be redone. If you take the time to go ahead and calculate a new objective function value just in case you're wrong with whether you could do it or not, it sure will save you points. Because if you accidentally say, no, that this is no longer valid, and it really was, and you didn't calculate the new objective function value, that's way too many points to lose. So you definitely got one of these, obviously, because this is a big part of analyzing these outputs. So we're now getting to where it's a little hard, to where you got to get familiar with these outputs to the point of being able to analyze them, whatever the case may be. By the way, I need to tell you the names of these. This upper and lower limit on these numbers that are part of the objective function, this is called the range of optimality. And you'll see that on the list of topics. Range of optimality means however much the numbers in the objective function could increase or decrease, and these are related to the optimal solution. However much they can increase and decrease and not change that optimal solution. In your PowerPoint and in the book, these ranges here with the constraint are called range of feasibility. And you'll see it on the list of topics. It's just however much each one of these right-hand sides could increase or decrease and not change those dual prices. So you can quickly see the effect. Here's why these are so important. Most of the time, these represent maybe raw materials from suppliers. This is the most common way this range of feasibility is used. The supplier was supposed to drop off 630 tons of aluminum, maybe. And this is what happens in real life. That supplier's calling and says, hey, I know I'm supposed to, we have a delivery today. We have 10 extra tons. And we'll give it to you for $3 a ton. Do you want it? Do you want to take it? We need to know now, because our truck's leaving with your order, and we can just throw these 3 tons on there. We need to know right now. Are you taking it? Yes or no? $3? Yes or no? Yes? Yes, no? Yes, why? This dual price represents the most you'd ever want to pay for additional units of that. And if they're saying it's $5 a unit, it's only going to increase my profit by $4.37, so why take it? Say, and be smart about it. You know, I want my managers leaving here going, no, but I'll take it at $3. Counter it. You know what the effect is going to have on your bottom line. That's how these are used in real life for quick decisions on things. Suppliers calling and offering additional, or here's a very common thing. We are supposed to be delivering 630 tons of aluminum. We've only got 600. So sorry. We're about to deliver it. You still want it, don't you? You know, you're looking at this going, is this going to change everything? I mean, how much is it going to affect here? If they're only delivering 600, and that's outside of this, you got to say, hey, wait, don't send the delivery yet. Let me recalculate things and see what effect this is going to have. Because it's outside this limit, the dual prices are no good anymore, our objective function value doesn't make sense, we got to redo the whole problem, make changes, recalculate, and then call them back and let them know if we want it or not. At the price, you know, are they changing the price because we're only getting 600 compared to 630? At this point in time, for every ton we're using, it's contributing to our profit by $4.37.5. So this is called sunk costs and relevant costs. Those are the last 2 subjects of chapter 3. So I'm going to go more in depth about how this is used related to this in making buying decisions. Because if you're working for a manufacturer, a lot of college grads will kind of get their feet wet as a buyer. And it's very common. And you're doing things normal, and all of a sudden, you're getting calls from suppliers going, wait. You know, you're not used to this. And these are the kind of things you have in front of you that you're making decisions with, or these outputs for the manufacturing process. So you can say yes or no. We have 4 suppliers here. In real life, you're going to have 50 suppliers of goods that you've got to analyze and say, yes, I'll take it at this price, or no, I'll take it at that price. We have that time? Wow. That's it. As far as we got.